Alright, to start off the second half of this chapter, we're going to talk about dilations, which is the last transformation that we're going to talk about in this unit. Before we talk about what a dilation is, we need to understand what similar objects are. Similar objects have the same shape but are different sizes. So, like, for example, I would have two triangles that look like this. It looks like one is just like the same thing but just zoomed in. So similar objects have proportional side lengths. What I mean by that is, like, let's say this is a 3, 4, 5 triangle. All of these sides would be proportional. So it looks like I took every side length and I multiplied it by 2. Since I multiplied by the same number, they're all proportional, I get that same shape. Also, which keeps these the same shape, is that they have congruent angles. So similar objects have proportional sides and congruent angles. So all the angles in here would still be the same. And think back to when, like, no matter how big or small we draw a triangle, remember that the sum of all the angles equal 180. So that would kind of make sense as well. So now we can talk about what a dilation is. A dilation basically just enlarges or reduces the size of an image. So sometimes it's denoted like this, capital D with N and C in it. N stands for the scale factor, and C is the center of dilation. We're going to assume that the center of dilation for, like, the first part here is always at the origin. We'll worry about that at, like, the later half of this chapter. Basically all that we do to make a dilation is we multiply the coordinate or side lengths by the scale factor, okay? So the scale factor is going to be really the most important thing to understand our dilation here. So in an example, I want to know what are the coordinates of the vertices of triangle PZG dilated by a scale factor of 2. That's how I'd read that. And I want to graph that new triangle as well. So when I read that, that basically just tells me that I'm doubling PZG in size. And I'm basically just multiplying all of my coordinates by 2. So what I would do here is I would write out all of my coordinates for P, Z, and G. And what I'm going to do to get my new dilation, so I'm just going to multiply every coordinate by 2. So in P I have 2, negative 1. 2 times 2 is 4. Negative 1 times 2 is negative 2. I'm going to do the same thing with all these coordinates. And I have my new shape, essentially. When I graph those coordinates, it does look like, so centered at the origin there, I just zoomed in on that triangle by a scale factor of 2. That new triangle is doubled in size. Last thing we'll talk about is finding the scale factor of an object. So again, remember that A prime, B prime, C prime, that would be the new shape. So it looks like AB was 12 units long, A prime, B prime is 6 units long. I could look at it and think, okay, I cut that in half, I divided by 2. We always want to think of scale factors in terms of multiplication. So dividing by 2 is the same thing as multiplying by 1/2. So I'm going to double check to make sure that's the same with the rest of my side lengths. So that one checks out, and that one checks out. So I can confirm that my scale factor going from ABC to ABC prime is a scale factor of 1/2.